What are magnetic fields and electromagnetic forces really? If you could see the media underneath instead of just arrows and formulas on a page? In the energy filament theory, they are not mysterious extra layers on top of physics. They are simply two kinds of patterns in a single energy sea, straight textures and circular textures that appear when charged loops move. Start with the calm case. Picture the energy sea as a huge flat lake. A static electric charge, like an electron or a proton, is a tiny loop of filament that has been pulling the lake inward or pushing it outward for a long time. Around it, the surface develops neat, straight ripples pointing in or out, like ring-shaped wrinkles around a fingertip pressing into a drum skin or bulging it from below. That region full of straight, directional lines is the electric field. It tells you, at every point, which way the fabric has already been stretched. But the story becomes more interesting the moment the charge starts to move. Imagine that same source gliding across the lake like a boat. The straight ripples it created did not vanish. As the boat moves, it drags those ripples sideways. At first, the rings are just tilted, then they bend into arcs. As the motion continues, the arcs curl into full loops that wrap around an invisible line running through the path. Under the surface, you now have water that is not just rising and falling, but also spinning around that line. Those circular flows are the magnetic field. It is not a set of ghostly lines of force drawn between poles. It is a real region where the medium is circulating around a direction, like water swirling around an invisible pole stuck through the lake. So what is magnetic force? Think about walking through still water and then stepping into a sideways whirl. In calm water you can walk straight. In a whirl, every time your foot comes down, the sideways current gives you a small nudge. If you keep trying to walk forward, your path naturally curves. A charged particle that already has some velocity does the same thing when it enters a magnetic field. Its forward motion continues, but the circular flow in the sea keeps pushing from the side. So the easiest path becomes a loop, an arc or a spiral instead of a straight line. That is why magnetic forces only act on moving charges and always bend their paths instead of pulling them directly closer or farther. Electric fields and magnetic fields now separate cleanly in your mind. Electric fields are made of straight textures and act along those lines. They can push or pull a charge even if it is initially at rest, because the fabric is already slopped in those directions. Magnetic fields are made of circular textures, and they only affect charges that are already moving. They grab the motion from the side and continuously redirect it. One is a straight slope, the other is a sideways twist. Now combine them and you get the full electromagnetic field. Picture a rope again. One hand pulls it straight so it points forward, that is the electric part. Your other hand twists it so it spins around its own length, that is the magnetic part. Let the rope advance while spinning and you see a traveling helix, a spiral pattern moving through space. That helix is a good visual for an electromagnetic wave in the energy sea. The straight component from the electric stretching and the circular component from the magnetic swirling locked together, chasing each other forward like threads in a screw. In textbooks this is drawn as wavy lines and right-angle arrows. In the sea it looks like a thin spiral ridge sliding across the surface. When a charged particle falls into such a helical region, both textures act at once. The straight part of the pattern tries to tug it along or against the direction of the ridge, while the circular part keeps nudging it sideways. The result is a rich variety of paths, gentle arcs in weak fields, tight corkscrews in strong ones, or neat circular orbits when speeds and fields happen to balance just right. You see the evidence all around. Electrons looping in circles inside magnetic spectrometers. Charged particles in Earth's magnetic field spiraling down toward the poles and lighting the sky as auroras. Or whole jets of plasma near black holes shooting outward as long, rotating beams that radio telescopes can trace for light years. In every case the media is doing the same kind of work. Some parts of the sea have been pulled into straight tension patterns. Other parts have been wounded into circulating patterns. Moving charges are simply following the easiest routes through that textured landscape. Once you see straight versus circular textures in the sea, Electric and magnetic stop being separated mysteries and become two faces of the same thing. How a charged loop deforms the medium when it rests, and how that deformation changes once the loop starts to move. Tap follow, share it on New Physics, Clear Universe.